Hi, I'm Matt, M0CUV, and here's a short video showing how propagation changes on 20 metres by plotting stations received via the JT65 JT9 digital modes on a world map throughout the day. I left my station listening to 20 metres over several days, including long weekends, around May and June 2016, decoding JT65 and JT9 signals using Joe Taylor K1JT's WSJTX software. WSJTX records all traffic in a log file that's easily processed to give incoming station locator code, date and time. Here's the log from the 16th of May 2016, and at 0450 I hear RX6DY in square KN95 replying to SV5BYP. Then ZS6WN giving a -12 signal report to OK1UA. RX60Y giving a signal report at 0452, and then a couple of CQ calls at 0454. I've written parsing software for this log format in Perl, and I've released it onto the comprehensive Perl archive network. Details to follow at the end of the video. The log data is then parsed to retrieve, for those log lines that record it, the date, time, call sign, grid square, power, and mode, hash being JT65, at as JT9. These records are then collated under their time to show the call signs, grid, power, and mode at a given minute, here from midnight onwards. With data extracted from several days, I ignored the date, giving me records showing which parts of the world can be heard at a given time. Now I need to plot this data onto a map. I wrote another Perl module, available via the CPAN, for producing the maps I'll show in this video. I've then plotted these stations, the locator grid, and the day-night boundary on a map for each minute's data. Note that these are stations I've heard, either calling CQ or replying to other stations, and also the stations I've worked. In the maps that follow, the red dots are JT65 stations, and green are JT9. The size of each dot reflects its signal strength, as recorded as M0CUV. The JT modes are excellent for DX contacts and studying propagation. So far, I've had contacts with these stations, mostly Europe and Asia, a few in America and Japan. My DX records are the most northern station, RW0BT, in Russia, square NP39, most southern, K7HJE, Florida, EL95, most eastern station, JI0JWV, in Tokyo, square PM94, and most western station, K8SIA, in Michigan, EN82. Let's see what I decoded over 24 hours. The time shown in the video at the bottom left is UTC, so starting at midnight. Europe's fairly active, a few stations in Asia, and you can see that the enhanced propagation along the day-night boundary is evident with the large activity on the east coast of America. Grey line moves into the mid-US. This is when US stations are strongest to me. More east coast stations, but night is falling on the US now, so we'll see a decline in signals from there. But Russia's waking up. Square KN becomes very strong. Iceland stops being heard now for 3 hours. Now seems like the best time to hear Australia. South Africa appears, strong activity now in Europe. A brief flurry of activity from Japan, but it'll be 11 when night falls there, when it really returns and stays. The Canary Islands, South Africa and Gabon. The west coast of America is now fading. RW0BT strongest now, and also a signal from UA0ZK in square QO on the far right of the map. The Azores, Dominican Republic, Venezuela. Japan returns and stays until midnight, also RA6ATV in square RN for a couple of hours. Indonesia appears. China appears. Daytime in America. West Coast stations being heard. European stations still strong, also Sumatra, Malaysia, India. South African stations start to appear. Now we start to see the effects of the grey line on propagation to the UK. Stations from Brazil and Argentina are starting to be heard, and Japan is strong. The grey line is now almost over the coast of Brazil and Argentina, and the east coast of America is active. Brazil and Argentina are now strongly heard in the UK, and also Japan. Europe is still very active. Squares JN, KO, KN are at their strongest now. American stations are starting to be heard stronger again now. I also hear Alaska in this hour. Good reception of stations all over North and South America. Europe is still awake at night, although fading. Europe is going to bed, but Greenland and the Northwest Territories of Canada are active. Let's look at this data another way, with the grid squares showing a heat map, red being the most active, yellow being least active. So if I compress all this data into one diagram, I can show when is the best time to work square X. It's a bit tricky to read though. In each grid square I've heard, there's a 24-hour clock showing when signals were heard, with the colour of each hour indicating the proportion of signals heard in that hour. Some squares are easy to interpret. FD, at the southernmost tip of South America, was only heard at 19 hours. OP, in Asiatic Russia, was only heard at 23 hours. Looking at Australia, 5 is probably the best time, but stations were heard at other times. South America is best heard between 19 and about 2 in the morning. In contrast, it's possible to hear nearby European stations at any time. If you'd like to plot your received station data from WSJTX, all the Perl scripts used to produce this are available as open source. There are 2 modules available on the CPAN, one for drawing maps, one for parsing logs. The main drawing scripts that use these modules are available as mercurial repositories from my Bitbucket page.